Welcome to the Let's Build session, 1 out of 2 for Happy Fire. And welcome back to in-person Dev Days. That's pretty fun. These sessions, I always find it's tough to figure out exactly what to cover, just because obviously you don't want to be, I don't know, throwing concepts out that are so tough that somebody can't approach it at all. They're supposed to be Let's Build, so it's supposed to be something you could theoretically follow along with. So it's always a tough balance. The way that I have organized these two is we've got a fairly basic session today and a much more advanced session tomorrow. So if anyone already knows the real basics of Happy Fire, sorry, you probably aren't going to learn a ton today, but maybe you will. Tomorrow, we're going to get into some more advanced topics, and there we go. If you want a preview of what we're going to be covering, there is a link up on this front slide to these slides. Please feel free to take them, do what you will with them. You can get a preview of what's coming tomorrow. You can also make copies and do whatever you want with them because, of course, like much of the content that FHIR produces, this is all open source and Creative Commons and all that good stuff. And that applies both to the material as well as the code that we're going to go through today. So this is me. Among other things, I've been leading Happy Fire for ages. This is my sidekick, Dharma. So what are we going to cover today? For our Let's Build, we're going to talk about the basics of the Happy Fire data model, how to use the parser, how to basically how to create a data mapper. Just because we see these days, like really common scenario is people trying to map existing legacy data into FHIR. So we're going to go through an exercise that does that. And then tomorrow, we're going to talk about securing a server that hosts that data. So that's probably a more advanced topic tomorrow, as I say, and we'll get a little bit into the interceptor framework as well as we talk about that. We only, of course, have 45 minutes together, and we have to leave room for questions even. So we certainly, this is going to be a real blaze through this content, but hopefully it'll be useful to anyone. I always like to start with this slide. I know that's probably really hard to see as it's a little bit washed out, but this is a map of Happy Fire users around the world. We take this from our developer documentation. It's a Google Analytics tracker and sort of shows us where Happy gets used. And I think it's a fun intro to the library itself. You can kind of see that we've got pockets of use pretty much everywhere in the world. I mean, there are some big gaps where we don't see use, but lots of population centers around the world see lots of use of Happy Fire. This is one of the more confusing concepts when people are getting started, both with FHIR as well as with Happy Fire, is around versioning. And I always have to stress that the version of FHIR and the version of Happy Fire are completely independent properties. Each version of the library supports several versions of the standard. We don't version them in exactly the same way, of course, because FHIR is a standard where Happy Fire is a software library, and they work pretty differently. But the version numbers are similar, and in fact, often are quite confusing. There was a good long period where the latest version of FHIR was 4.0.1, and the latest version of Happy was some 4.x series, and that really confused people. Those two version numbers have nothing to do with each other, and in fact, we've just bumped our Happy Fire version number up to 6, so we're now beyond even where FHIR's version numbers are at. As you can see from this chart, the current release, that bottom line says 5, 6 has not changed yet, so it still applies to our current release. We support DSQ2, we support R3, we support R4, and we support the current drafts of R5. We've had a lot of questions about R4B. I was really hoping to get that into the 6 release. We didn't make it. But I'm sure we will get that in probably in the next month or two into a pre-release version of Happy anyway, and we'll have some GA ability to do our 4B support by our August release, whenever that happens, probably 3rd week of August or so. So a quick whirlwind tour of the Happy Fire library. We've redone this diagram a few times over the years because we keep adding new things to it. I wonder, does my mouse work? Yes, it does. That's cool. So the major components of Happy Fire, and we have tried really hard to stick to making a library that is sort of fairly modular and fairly decoupled, such that if you want some parts of the library but don't need others, You don't need to pull in the pieces you don't need. Lots of bits of the library can be used independently of each other. So we've tried pretty hard to keep the coupling low around the major portions of the library. We do, of course, have a complete set of data model classes that represent all of your FHIR objects. So, your patient resource, all the data types inside it, your encounter resource and all of its data types. All of that is represented as Java classes. We've got a patient.java and a string DT or string type.java, all that good stuff. We've got parsers and serializers that cover all of the major encoding formats. Your JSON, your XML, and your turtle encoding, all of those are covered. We've got a client framework, and we're going to be playing incidentally today with these first three things: the model, the parser, and the client. We've got an Android framework that builds on the client, which is sometimes used, not probably one of the more heavily used parts of the framework, but does exist. We've got what we call our plain server, which is our facade server. I'm not going to be talking about the plain server today, but we are going to be spinning one up as a part of the exercise. And there is code that if anyone wants to try this on their laptop later, you certainly can. We've got this thing called the JPA server, which is a complete data model server in a box. A couple of things that extend on that, including our MDM framework, better known as the EMPI framework, as well as the CQL execution stuff that layers on top of the JPA server. And then down the side, our interceptor framework, which is used to layer all kinds of good functionality on top of pretty much the entire rest of the stack. And we'll talk a little bit about interceptors, probably actually not even at all today, but we'll get into interceptors a little bit tomorrow. I'm not going to be covering probably much of the other modules that are in here. There are tons. There is lots of good content on all of this stuff on the web either way. And I'm going to pop up the FHIR website in a minute just to walk through where all the good documentation is for all this stuff. But there we go. And we've got a bunch of built-in interceptors, which we'll be playing with during the interceptor portion tomorrow. So let's dive into code for a minute. I'm going to start with just screenshots of code. And towards the end, when we get into the let's build portion of this, I will actually pop into an IDE and we'll play with some code for real. But this is the real basic hello world of working with Happy, creating a resource. So every resource type in FHIR, as I said before, has an equivalent Java class that exists within the Happy FHIR library. In fact, we've got versions of these classes for each major release of FHIR. So there is a different class for the DSQ2 version of FHIR than for 3, for 4, for 5, which is sometimes a bit of a pain in the butt, but is in many ways necessary just because the standard, of course, continues to evolve. So we've got copies of many of these classes. Dealing with it is a fairly easy thing. I mean, I'm not going to walk through every line of the code that's on the screen. Hopefully that's big enough font that everyone can read it from the back. I mean, effectively, the things that I'll draw your attention to, certainly we've tried really hard to work with this, what's called a fluent interface design. Sort of the idea here is that something fell. Everything chains together. So generally speaking, if I'm adding a name to a patient, for example, I can call add name, I can call set family to give it a family name, and then I can just chaining on these add given names as far as I go. And in fact, many times when you're writing this code, I'm sort of splitting some of these lines up just for readability. But honestly, when I'm writing this stuff myself, this is all going to be one line typically: add name, set family, add given, and it all just joins together. And this applies to all sorts of different data types around the library. So this is obviously a couple of examples of simple properties that we might want to feed into our patient resource. Certainly, the whole API is designed to take advantage of autocomplete in whatever IDE you're using. I would absolutely recommend get the Javadoc jars as well. And however you're doing your builds, I mean, if you're using Maven or Gradle or any modern build system, those systems will typically download the Javadoc jars for you automatically. All of the Javadocs are code generated, so everything in the model classes comes straight from the FHIR spec. That part is important because it means that all the Javadocs on the individual methods come with the FHIR definitions for the things that they're describing, which ends up being sort of nice as a developer. You can kind of pick through the methods and, I mean, I think for patient, it's not always that unclear what you're talking about. But for many of the other resources where it might not be obvious what a field is, you can often sort of look at the Java docs and figure out what's going on as you're developing. I'll mention quickly enumerated types. This is a gotcha to people who are just starting with the library. We do define Java enums for many of the coded fields in the FHIR standard. With this weird caveat that we only do it for what FHIR calls closed bindings, which is closed bindings. This is one of these more advanced FHIR terms that if you really want to sound like you're a FHIR pro, talk about binding strengths, and you'll have everyone figuring you're a total genius at this stuff. I don't know. I love the way it sounds. Closed binding strength and all that. Binding strengths in this case, what we're talking about effectively is in the FHIR spec, there are coded fields where you are forced to use one of the codes that FHIR itself distributes. Gender on a patient would be an example of that. You can't define your own gender codes. You have to use one of the 4 that come with the FHIR standard. On the other hand, there's lots of other coded things where that's not the case. A marital status, for example, FHIR does distribute a set of codes you can use there, but you're not required to use one of FHIR's codes. The required binding, what I was talking about with that gender code, that's a required binding, meaning that you have to use one of the FHIR codes in that field. And the reason I say all of this is to say that we use Java enums for any of those required bindings. We don't use them for any of the non-required bindings because, of course, in Java, you cannot extend enums. So that would not work. Primitive data types, another weird gotcha when you're getting started with the library. FHIR, of course, defines a complete set of data types, actually a really exhaustive set of data types covering, I mean, all of the things you would expect as a programmer for something like this to have. There are data types for strings and numbers and decimal numbers and integers and, I don't know, coded fields and all the usual things you'd expect. There's also a bunch of data types in FHIR that are perhaps, I think, to a programmer a little bit weird. And I guess you have to recognize that FHIR is an exchange standard, not a programming language. So it just calls for more extensive data types. So FHIR's got data types for things like URIs and URNs and base 64 encoded data, all these sort of odd things. We have defined a data type class for every one of them. They follow the type or the naming convention of just the name of the data type and then the word type at the end. So you can see a few examples here: date, time, type, and Boolean type, and decimal type. Most of these classes are really just wrappers around some sort of equivalent Java primitive. So the Boolean type, for example, is just a wrapper class around a Java Boolean, which just seems like a really weird thing to do. Certainly, I think anyone who gets started with this library sort of wonders why we're wrapping a Java Boolean at all. Like, why do we need to make that a thing? The reason we do that, there's 2 reasons I do that, and this is sort of why I focus on this bit, just because it's weird, but it actually has a purpose in FHIR that ends up mattering in a few places. One, these wrapper types keep track of both the underlying primitive, but also the string representation of that primitive. And those things in some cases are identical, but not all cases. A simple example of where they are identical, of course, is the Boolean. The Booleans can only be true and false, and the string version of that can only be the word true or the word false. So that's a nice, easy one. Decimal numbers, though, are a little bit more tricky because, of course, as I'm sure we all know, decimal numbers in FHIR, the precision of the significant figures do matter. So the string 1.20000 is not equivalent to just the string 1.2. Where if you've got the native FHIR equivalent to that, that's just that's a decimal number, 1.2D. That you can put as many zeros after that as you want. The compiler will just discard them. It doesn't care about them. So we do keep track of the string version of that just in case it's ever needed. And there are cases where you care. That's one reason we do that. The other reason we have these wrapper classes, and this is perhaps even stranger to people who are just getting started with FHIR, is the concept of putting extensions on primitive data types. This is one of the weirder things in FHIR. If I'm honest, I've never loved that it's even a thing you can do, but it is a thing you can do, so no changing that fact. We do use these wrapper types. If you need to add extensions to a primitive, you would add it right to this wrapper class. Typically, you don't need to interact with the wrapper classes. Most of our setters and getters have two ways of dealing with them. The observation resource, as a simple example, has a property called comment, which is just a string property. And as you can see here, you can sort of deal with it by providing a string directly in. There's this set comment element or set comment method. There's also a second version that interacts with the underlying wrapper primitive class. And certainly if you wanted to add this comment and have an extension on that comment, you'd have to use this second form. And of course, getting data back out of the model works the exact same way. There's a getter for both the string version as well as the wrapper version of it. Sort of the beginning, the gateway into the entire HappyFire library, and this applies to pretty much anything you will ever do with HappyFire, is this class called the FHIR context class. It's really, as I say, it's the gateway to sort of everything. You can ask it for parsers, you can ask it for validators, you can ask it for clients, FHIR path expression executors, you can use it to build servers. So really anything you'd want to do with Happy probably starts with a FHIR context class. One of the biggest anti-patterns in HappyFire, and this is why I like to stress this, the FHIR context is designed to be created once and reused as widely as you possibly can. It's a fairly heavyweight object. It does a bunch of initialization, but it's really thread safe. It doesn't leak memory or anything like that. So it's just fine to create one, even create it in a static variable and hold it for the lifetime of your application. Just don't create a new FHIR context every time you need to do a client request or parse a resource or something. You will have big performance problems if you try and do that. So reuse FHIR contexts as widely as you can. Quickly, we'll play with a parser. This is an example of serializing a resource. And I guess a quick note there, we in HappyFire use the word parser to mean parser serializer. Many frameworks sort of split those two concepts. We combine them into a single thing called a parser. So I'm encoding a resource here and I use a parser to do that. Effectively, I will always create a context object. In this example, I'm creating a context for the specific version of FHIR. This is a DSTU3 context. I ask it for a parser. There are all kinds of configuration options I can throw on that parser, including in this case, pretty printing, which is of course nice, new lines and indenting and all that good stuff. And then I use the parser to encode to a string. And of course, when I do that, what comes out but a nice serialized and indented version of the contents that I had stuffed into that resource. Parsing, which is the other direction, of course, is pretty much the same thing. In this case, I'll take an input string, which looks really ugly because, of course, I have to escape my quote marks in there. But this is a resource. I'll create a new context once again. Ask the context for a parser, and then the parser has this parse resource method. And from that, I can pull out any information I want. So in my simple example here, I'm fetching the system and the value and logging them. And what comes out, of course, it is the system and the value, which we're sitting right in here. Clients, quickly, I will say, we have two different flavors of client in HappyFire. There is this thing called the annotation client, which is, it's sort of a client that would look familiar if you're used to things like the JAX-RS framework or the Spring's REST framework or REST Easy, or if you've been around long enough to have done SOAP development, all of the old SOAP clients typically worked this way as well. That was actually the basis for the original design in HappyFire. I'm not going to talk about the annotation client. It was the first one we wrote, but the second form, the generic or fluent client, became much more popular. So it's, I don't know, we continue to maintain both, but I've always found the fluent client more pleasant to use. And I think most people these days agree with that. So a quick example of using a client, I will create a patient object. And I'm not showing the lines to actually populate it with data, just so that this fits in a nice readable size on the screen. But pretend we're filling in a bunch of fields on this patient. I'll create a context as we do in HappyFire. And then I'll ask that context for a client. And the client, all you need to give it is a base URL for a server. So this base URL is the URL for our public HappyFire testing server, but this could be any other server you wanted to talk to. Certainly this could include, people often look at this and think, that's great for your public unsecured server, but my server has got, I need usernames and passwords. Why are you not providing those here? And the answer there actually comes to interceptors, which we'll talk about tomorrow. So when we create clients, all you do is give it a base URL for your server. And then the client itself basically takes this little fluent method call. So I say client.create.resource.execute. And that ultimately is the exact chain of events that will lead to the client going out, talking to the server, constructing the exact right HTTP post, serializing your resource, creating a URL, transmitting it over, parsing the server's response, and ultimately returning back what we got back from the server, which is this outcome this outcome object. And the outcome object has a bunch of properties, certainly including the ID of the resource that we just created. This is a good opportunity to jump onto the FHIR website. So I will do that quickly. Whoops, there we go. I do this specifically to go to the documentation. And I'm gonna say a couple of things about the docs in FHIR, just because as I say, we really don't have time to get into almost anything of really all of the many nuts and bolts of this library. But the docs, we've worked really hard on them. They are pretty exhaustive. There's a lot of stuff in here, certainly including lots of details around parsing and serializing. I will say the one thing I'll draw your attention to is for each major section of the library, certainly including the client, including the plain server, including the JPA server. You'll notice these little links that say get started with a lightning bolt. And if you are looking yourself to get started with plain servers, for example, and I'm not at all going to talk about plain servers today, so this is a good example. If you want to get started with plain servers, you probably want to read the rest of the docs just to see how they work. But where you might choose to go from there is the Getting Started page, and that will take you to links for GitHub projects, which are working skeletons that will get you started using that module of the library. So a nice, easy way to get started with that library. So that's thing one. Thing two that I wanted to draw your attention to is, as I showed you before, let's go back a slide. Oh, that's probably hard to read. I did sort of show you there's this weird little chain that you had to call here, client.create.resource.execute. I've typed that so many times I can do it in my sleep, but I realize it's not entirely intuitive that those would be the exact methods you would call to functionally do a create in FHIR. But don't stress, I'm going to go back to the website. I'm going to click on the Fluent client. And I will point out that every major FHIR operation, there are lots of examples. So let's pick one. If I wanted to do a delete, for example, how do I do deletes? Here's an example of how a delete works. And there are lots of examples on this page for all of the things you might want to do with the FHIR client. There we go. So the Let's Build session for today. And how are we? Oh, we're great for time. Awesome. So what we're going to do today is we're going to basically create a little application that takes in CSV data, maps it to FHIR, and then uploads it to a server. I'm not going to write the entire thing, but I'm going to get started in this. And I think what I'm going to do is anyone that actually wants to give this a shot, I will leave that as an exercise for later. We can talk about it a little bit tomorrow. We could even talk about it on the mailing list. Or if you want to see, I'll show you in just a second, there is a working complete solution. So if you'd rather just see how it all works and not sort of suffer through it, that's just fine as well. It is kind of a neat exercise though. And this is all open source. So certainly if anyone wants to take it and share it with colleagues and sort of try it on their own time, that's a-okay. So what we're doing is we're going to take a CSV file, and that CSV file has a bunch of lab test results for basically sort of a fictional set of patients. I don't know that I talk about the origin of the CSV file, but this comes out of it's an open data set that was produced, I believe, by the CDC. I know somewhere there's attribution in that file. We'll find that in just a second, I'm sure, because I'm blanking on where it comes from. But it is a really neat little set of data. And what we're going to do is, just because this mirrors a problem that lots of people have in the real world these days, you've got a bunch of data. It doesn't look like FHIR. Maybe it's in a data warehouse and we can extract it, or maybe it's stuffed in relational databases or sitting in flat files or something. We want to convert it to FHIR, and we want to upload it to a FHIR server. definitely a problem we've seen people have to solve quite a bit over the last few years. The CSV file we're going to use as input, and I'll show it to you in just a second, but it's basically, it's got a set of attributes that map to two different resources. So every row maps to two different FHIR resources. You've got your information around your patient, and you've got some information about observations. And of course, we're going to skip a couple of important properties. I do highlight that just so that this exercise isn't too onerous. If you were doing this for real, you would be populating categories, and certainly you'd want to get reference ranges in there and interpretations and various other things that you have to have for observations. I'm skipping a bunch of that just to keep this to a manageable scope. But here we are. So this basically, this is where I'm going to pause for a moment and say these, if anyone, I will at the end bring this back up so you get the links to both the slides as well as the GitHub. But I'm going to get out of here for a second, and I'm going to drop into that GitHub repository that has our Let's Build exercise. And I'm going to start with, I think on here somewhere. Oh yeah, here we go. So the source of the data set we're using, it comes from the National Health and Nutrition Examination Study. So it's neat. This is actually a de-identified set of real lab test data that was published by the CDC. They actually didn't provide any identities for the patients. So I went in and added some fictitious ones just so that the data would be a little bit more useful. But these are real results that have been reattributed to fake people. A simple example of what's in here, this is a line from the file. So we've got the sequence number, which we can choose to do what we want with. We've got a timestamp, which corresponds to when was this taken. We've got an ID for our patient. We've got some demographics around our patient. And then we've got three values. We've got a white blood count, a red blood count, and a hemoglobin count. So we've got these three numbers, and we want to take this, and I think everyone will recognize, I mean, this row in this file kind of makes sense, but clearly looks nothing like FHIR. So our exercise is take this stuff and turn it into real FHIR data. And of course, you will see here, I've got explanations for how all these comments work. And then we've got details around how to make a mapper class. So let's go drop into an ID. I'm hoping, let's make that a little bit bigger. No, bigger. Oh, of course, this won't get bigger all of a sudden. Zoom. Well, that is refusing to get bigger. Hopefully that's at least somewhat legible in there. Yikes. Here's our sample data file. This is the actual complete thing. You'll see that most of the happy FHIR examples out there focus on Simpsons characters because I love the Simpsons. So this one is no exception to that. We've got Marge and Bart and Lisa and Maggie and Homer with their various lab tests and dates associated with those lab tests. So here is the skeleton to work from. So we've got this class called CSV data uploader. It's really driving me nuts that I can't make this thing get bigger. Why is that? Bear with me for a moment. There we go. Hey, I knew that was possible. Okay, so yeah, that's more like it. All right, that's what I wanted. Nice big text. So the skeleton that we've got here is effectively, I've written out the code for going and reading in the file. I've parsed it as a CSV file. We've got a little iterator that loops through all the records in the file, and we pull out all of the values. And naturally, we're not doing anything with any of those values. So the exercise as it stands is to go through and basically and create a mapper and then upload the data into a server. The other thing I will point out from the README file in this GitHub repository is a part of this repository is a little built-in in-memory FHIR server. So this command here, I'm going to open up a console and I'm going to run this command right from where I've checked out this directory. And if I run that, what I'm actually doing is spinning up a little tiny running happy FHIR server completely in memory. So if I restart it, it's going to lose all its data. This is obviously not a production grade server at all, but a really nice server for testing. I've now got a little running FHIR server at localhost port 8000. Let's go play with it for a second. So if I do a search on that, oops, that was it's just the base URL. If I do a search on that for patients, you can see I get 0 patients back because nothing is in there. So let's try adding something. I think this is kind of fun. So on our context object, we're going to ask it for a client. New RESTful generic client. I'll put in my base URL. And now I've got a client. And what I'm going to do just with us together is I'm going to create a really basic patient object. So I'm going to take the patient. I'm going to create a patient. Coding live in front of people is always so nerve-wracking, as I'm sure everyone will appreciate. I'm going to populate my patient ID. And I'm only going to give it, I'm just going to give it an ID and I'm going to give it a family name, just because I don't want everyone to watch me struggle to type in front of people for too long. So there we go. I've created a patient, I've given it a family name, and I've given it an ID. Last thing I'm going to do is I'm going to use my client. And I'm going to say, I'm going to use a client with client assigned up. I'm going to use an update with client assigned ID, which is basically this mechanism that says, I'm going to give you a patient, I'm going to give you its ID, and this tells the server if there is not a patient on the server with that ID, then create one, and if there is one there already with that ID, update it. So we'll give it our patient, and I'll call execute on that. And there we go, this little bit here. I've created a patient, and I've given it a name, and I will call update. I will call update to put it on the server. Let's try running this thing. Oh, good times. What do we not like here? Oops. We had a little placeholder for something we were going to start tomorrow, and apparently I forgot to comment it out. Let's try that again. And round it goes. So you can see in the logs, those are probably hard to read. I'll make it a little bit bigger. The logs go through. I had added a log line near the start processing row just so you could see some sort of activity in here. And it's gone through and it's created these guys. Let's go back to our server now. So remember the last time I did it, last time I searched it, there were no patients. This time I'll search again. And we've got lots of patients. So we've created, of course, I should have probably given it a given name because they've all got the same family name. So we've now got a bunch of patients that have the same family name. Bit weird, but oh well. You know what? Let's fix that. We have time. So we'll add one more chain to that. Add given patient given name. There we go. Oops, not S. Let's run that once more. There we go. Run it a second time, so now each of our patients has a family name and a given name. So nice little patients on the server. I'm not going to take you through every last bit of doing the mapping because that would be super tedious to watch. But I will point out if you'd like to try this on your own, awesome. It's a neat little exercise, and I think representative of something you might do in the real world. You'll notice in this project there's this other class called hint complete. This has a complete working solution. So if you go into here, every last bit of data has been mapped. We create the observations, we create the patients. And just for fun, I'm going to run this guy now to actually upload all of the real data in there. So that has now created tons of data. We'll do our search once more. Oops. So we've now, the second time I ran it, now we've got genders because that was mapped. And perhaps more interestingly, we've got observations in there as well. So that's our exercise for tomorrow. Or for tomorrow, for today. Hopefully that made sense. As I said, if you're interested in the sort of more advanced stuff, what we're going to do tomorrow is take this server and add a security layer to it. So we're going to go through interceptors. And we're going to sort of show how you might set up rules that would allow a user to be able to see one patient's data, but not a different patient's data, which is also a pretty common scenario. So that's what we're up to. So with that, I will bring back the URL to the slides. And we have time for some questions if there are any.
Thank you, James. That was awesome. I know you've answered this, I'm sure, 100 times before, but I'm yet to hear the answer, so I'm really curious. The reference to UHN in the library, can you explain that?
Yeah. Oh, yeah. It's. I mean, the deal is just the library was started at UHN. So UHN, for anyone who doesn't know, is a teaching hospital in Toronto, Canada. At the time that we started the FHIR library, I worked there, and we actually used this as a basis for a product we were building there for internal use. Decided to open source it, and that has ended up a part of the package structure that we export as a part of FHIR. The library is no longer maintained by UHN, oddly enough, but I don't know, changing Java package structures is just really annoying for anyone using the library, so we've never updated it. That's all there is.
Thank you for the presentation. Does FHIR has, I see it's basically doing, the data mapping is basically doing the transform. Is it transforming all sorts of data regardless of how the EHR is sending it out?
So, so the question here is, is FHIR have translators for various other, like for EHRs and how they represent data? Is that effectively it? So I guess the idea there is FHIR has data models for all kinds of, for all of the different versions of FHIR. We've actually got a second sister library that's an HL7 version 2 library. It's just called Happy for HL7 version 2. We don't actually include any translators between formats within the library. Really, the way to think of Happy is it's a set of building blocks that you can use to build those translations. So if your use case is, I don't know, like a really common use case, for example, is I'm receiving HL7 v2 data and I want to convert that to FHIR and store it in a FHIR database. Like that's a really common thing to want to do. We don't supply as a part of the library any built-in translations between those two standards, but we do have data models and Java objects that speak both of those protocols, so you could build such a translation. And that's a really common thing. The other bit, which I didn't really get into here, but another really common problem to solve is, I've got a database. That database probably has nothing to do with FHIR. Like it may well predate FHIR even. It's got a bunch of data in it. And I want to put a FHIR interface on top of it so that people can use FHIR clients to get the data out of my database. And often that database is like the backend for an EMR or something like that. That is actually purpose number one that we built this library for. The module you use there is what we call the plain server. And the plain server sort of allows you to bolt a FHIR interface on top of an existing database. We don't do the data translation like for your sort of arbitrary data schema in your database. Of course, we can't automatically convert that to FHIR because we don't know anything about your schema. But we will take care of all the serialization and the REST protocol and all that good stuff. You just have to write the storage logic that sits underneath it. That's called the plain server in FHIR. Sure.
So there's another question coming in through Ruva. Does FHIR support / create classes from structure definitions for logical models?
Oh man, yeah, this is a tough one. We've had people ask about this for years. And I mean, unfortunately, the short answer is no. We have way back in the really, really early days of FHIR, like DSTU1, which we don't even support anymore. We did have a custom code generator that would take they were called profile resources back in those days. Like the resource name was actually profile. Doesn't even exist anymore. It's gone on to be replaced by structure definition. But we did have code back then that would take a profile resource and generate code on top of it. That stopped working when the profile resource went away. And we've had a few attempts over the years to rewrite something that would take a structure definition and create equivalent Java code. Much of the infrastructure exists for that to work, but we have never really closed that gap. We've never really created a code generator for logical models. It's something I've always wanted to do. We've just never found the time. So I guess I will say, if anyone is ever interested in helping with that, I mean, we are a big open source project. I think I dropped a slide that talked about this, but I will go back to it. If something I always like to point out to people, this is our main GitHub repository. And if we look down the side to the contributors, there have been 179 people have contributed to the repository to date. We are a very open project. We welcome any kind of outside contributions. I mean, this is the worst answer possible to do you support X is, can you build it for us? Of course, I know that's a weird way of answering that question, but I will say if anyone ever wants to help with any of the stuff we don't support, we do absolutely welcome the help.
Is there any other question from the audience? No, there's also no questions left from Ruva. But if you have any questions left, you can still post them, of course, in the Q&A. And then I think James will be able to attend to these questions later on. So we will have a short 10-minute break, but please feel free to